So I'm going to look at two problems involving graphs of rational functions. And I just want to caution you, as you're using your graphing calculator, they're great for giving you kind of a general idea of where things are at and their relative shape. But before you grab your calculator, it's really a good idea to sketch out and know where the zeros of the function are, where the asymptotes are, so you can kind of see those big behaviors before you grab your calculator and take a look at them. So let's take a look at this first one. I want to remind us just of a couple things here. So I put some things over here. It's too big. Let me zoom out and take a look at them. But if we're looking at zeros and vertical asymptotes, pretty straightforward. Anytime that we set the numerator equal to 0 and solve for it, that gives me zeros of the function. So set the p of x equal to 0. Wherever that function p of x is 0, that's a 0 of the function. And we set q of x down here equal to 0. And that gives us vertical asymptotes, right? Wherever q of x is 0 is vertical asymptotes. So that's zeros and vertical asymptotes. The next thing on here is horizontal asymptotes, and there's three cases we have to consider. And we've talked about these in class and looked at this. But so we're talking about the degree of the polynomial, and we've discussed what that means. But when you're looking at a polynomial and its degree, right? If the degree of the numerator is larger than the degree of the denominator, then there's no horizontal asymptotes. So that's about horizontal ones. If the degree of the numerator is smaller than the degree of the denominator, then there is a horizontal asymptote at the line y equals 0. And then finally, if the degrees are the same, what we're going to do is take the leading coefficient of the numerator and divide that by the leading coefficient of the denominator, and that will be our horizontal asymptote. So when we come back to this problem, we can see the degree here of my numerator is larger than the degree of the denominator, so there's no horizontal asymptote. The vertical asymptote, though, you can see I'm going to just set the denominator equal to 0. That's pretty easy, right? X equals 0. So actually this line, right, x equals 0 is indeed a vertical asymptote, rather. There is no horizontal asymptote here. Now let's go ahead and set the numerator equal to 0 and see if there's any zeros of the function. This looks like it's pretty straightforward to factor. We've got a let's see, minus 4, so we've got minus 4 plus 1. So that is equivalent to my numerator, so I can see that I have two zeros, one at positive 4, 1, 2, 3, 4, there's a 0, and I've got another one occurring over at negative 1, so there's a 0. Again, no horizontal asymptotes and just the one vertical asymptote. So at this point, let's grab our graphing calculator and take a look at that function. So I went ahead and typed that function into the graphing calculator ahead of time. You can see my numerator is set off with parentheses. I've got x squared minus 3x minus 4. And my denominator is just an x. I'm going to hit zoom. And I'm going to go down to standard view and graph this function. And that's great. That's pretty much what I thought would be going on. Now, the one thing that I might want to do to kind of enhance my graph is just pick a couple of values here and try and figure out where they're at more accurately. So if I'm trying to make a more accurate sketch, I'm going to go ahead and activate the table view. And I'm going to go down to, for example, I can see at negative 1 I was at 0. At negative 2, interestingly enough, I'm down at negative 3. So why not plot that point? That's a nice point right there. At negative 3, I'm at, it looks like negative 4 2/3, so negative 3. And that's a nice point to graph. And it looks like I'm at, let's see, at 1, positive 1, the graph is at negative 6. So that's kind of off the scale here. 1, 2, 3, 4, 5, 6. At 2, it looks like the graph is at 3. At 3, I make it up to 1 1/3. Oops, 1 1/3. And then if I go to 4, I'm at 0, of course. And then 5 is at 1.2. 1.2. And 2 is 2 1/3. Or no, right past that. 6 is 2 1/3. That really? That surprises me. Oh, I know why I'm surprised by that. I didn't put 1 1/3. This is the wrong point. Actually, let me get rid of that point. At 5, I'm supposed to go to 1.2. I'm fighting this next point because it clearly isn't fitting it. And then I go to 2 1/3. So 1, 2 1/3. That's better. And then at 7, I make it to 3.4. So 7, 1, 2, 3. 1, 2, 3.4. A little less than 3.5. Okay, so, it's a little thing, but by using the calculator to, first of all, using some information I had about asymptotes and zeros, both the zeros of the function and if they existed, y-intercepts, I get a better idea of what's going on, but then by plotting these points, right, I'm able to sketch a much more accurate curve. So I'm just going to go ahead and grab these and just come through these points. And again, it doesn't have to be a science. It's not perfect. I would ask for a piece of graphing paper, a printout from my computer if I really needed a perfect graph. Okay. So this is my graph. I can see my, some of the things I probably should label on here is that I've got some zeros. And this is an asymptote. XYM. Okay, let's look at another function. Okay, so for this function, I'm going to go ahead and again set my numerator equal to 0. Whoops, it's x minus 2 equals 0. And once I do that, x minus 2 equals 0. Once I do that, I can identify the zeros of the function, right, which I have when x is 2. So I'm going to be crossing this point through that point right there, and I don't know if I'm coming. I got to be careful. I don't know if I'm coming this way or this way. I don't know anything. I just know that it's going to come through that spot. The next thing I'm going to do is set my denominator equal to 0. That is the difference of 2 squares. So that factors as x plus 1 times x minus 1. So that gives me 2 different asymptotes, right? These are vertical asymptotes. One of them is going to be at x plus 1. So this is an asymptote. And the other one's at x minus 1 right here. Now, on this function, right, you can see that what am I trying to say? For this function, the degree of the numerator is smaller than the degree of the denominator. And whenever the degree of the numerator is smaller, right, I know that I have a horizontal asymptote at the line x equals 0, or y equals 0. It's the x-axis. So I'm trying to put a dashed line through there. It's not really showing that. But this x-line, this x-axis is an asymptote as well. Right, as are the 2 dotted lines. Okay, so pretty much I've decided everything that I can about this function at this point. So now I'm going to go ahead and graph it and take a look at it. So I went ahead and typed that function in again. And when I look at it, it's kind of interesting. Take a look at this. So here's one of the problems, okay, that you may not be aware of. This calculator right now is set on a graphing method that's called, I think it's called connect. There's 2 settings for the graph. Let me hit to that mode. You can see it's connected or dot. What connected does is it will take the very last point that the calculator plots, and it'll connect it to the one that appears after that. And that creates kind of an interesting artifact right here. I know that I've got an asymptote at this line, but you see this calculus coming down here, and then it's like jumping way up here. None of these lines exist, but it's still jumping through and drawing that as a continuous function, and it shouldn't be. So I'm going to take my calculator, whoops, and I'm going to turn off connected and put it on just dot. Now, it won't be as smooth as a curve, but every single thing that I see, I know is really a point that's actually plotted. So when I hit graph now, that's super difficult to see as well, because now I've got a kind of a different issue. I'm going to hit a zoom box and try and get a little bit more of the graph that I want to see. I got a pretty good idea what's going on, but let's see. This is not working well for me on the virtual TI. Okay, I paused the video, but I went ahead and put a zoom box in, and I'm going to press enter, and it'll zoom in on that spot. Still not fabulous, but I hope you can see why it's better to have an idea of what's happening with these asymptotes before you just try to just sketch it without really seeing what's going on. So I got a pretty good idea of the general shape of this thing, right? I know I'm going to be coming down here somewhere, and then there's something happening up in here, and then it's coming through, going through this too, and doing something. Just to clean this up a little bit, I am going to go ahead and look at some of the actual points from my table. So I'm going to go ahead and hit table, and I want to go to some of the negative numbers. I'm going to go back to like negative. Yeah, if I'm at negative 10, that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's right there, right? It's at 0.121. When I'm at 4, I've almost reached the half. Right? At negative 4, I'm at 0.4, so that's 1, 2, 3. So I'm right here. If I go to negative 2, I'm at 1 1/3. That's negative 1, negative 1, and 1/3. So I'm pretty happy with what this is looking like. Right, I'm coming along here. Definitely, this is a horizontal asymptote, and then I'm coming along, and now I'm approaching this vertical asymptote, not crossing that line at all. So that's the first part. Now, I want to set this table up a little bit differently so I can type in some values I want to see. Right now it's set to auto. I'm going to let it ask me the values I want to see. Because I want to put in a couple more values here. So let me go back to my table now. Oops. Not that table. And let's see. Let's put in negative 0.5. So at negative 0.5, this thing is at 2. Really? Huh. And then at 0, it is at 2 also. That's interesting. Now what is it at negative 0.25? Oh, no. It's at 2.4. What? At 0 is at 2. Oh, because I didn't put negative a half in like that. Let me put in negative 1/2. Okay, so at negative a half, it's 3 1/3. So at this point, let's see. It's awfully hard to erase these points sometimes. Let's see. But at negative 1/2, it's at 3 1/3. So 1, 2, 3 1/3. And then I go down to 2. At 0, I'm at 2. And right here, it's about 2.4. And at a half, it's back up it's oh, at a half it's still 2. That's interesting. And then at oh, that was a positive half. Let me get that right. A positive 1/2. Yeah, it's just, I'm just going to draw a line that comes in here. And I should have thought about this earlier, but when I was looking at this function, right, if x is 0, when x is 0, this whole thing becomes -2 divided by -1, so it equals 2. So it shouldn't surprise me at all that I'm having this y-intercept at the point when y is positive 2. And then, the last thing here, I know if I'm at, what, 1.5. 1.5 tells me I'm going through -0.4. 1.5, -0.4 right there. And at 2, I'm at 0. At 3, I'm at 3, I'm just holding my line. At 4, where am I? Yeah. Okay, so I think I can confidently sketch this thing too. So this is an asymptote. It comes through, crosses through right there, and then just kind of trails off this way. What if I put like 100 into this function? What does it do? No, cut it out. Go back to the table. If I put 100 in, it says, oh yeah, it's crazy small. So it's interesting. It does cross through this point right here, but then definitely behaves like an asymptote, where this line actually comes back and gets closer and closer over time. Well, anyways, that's a look at two different functions. I don't know if that's helpful or whatever, but that's basically the strategy I use when I'm trying to get a good look at what these functions are doing.